Okay, so this is a problem I saw on MSc. I think it resurfaced, or maybe it was like asked recently. So yeah, it was a pretty good problem, and it's got like a really creative approach. Like you wouldn't think someone uses functional analysis on a question like this, but yeah, functional analysis is like the best way to do it. Anyways, so we've been given that cosine of 3x is equal to minus sine of 3x, where x is in the interval 0 to 2 pi, the closed interval, right? So yeah, you can have 0 and you can have 2 pi. Okay, so first of all, we're going to use, I suppose, because I've said functional analysis now, so you know by this point that I'm going to use the property of the sine function being an odd function. So okay, I'll draw a rough graph for you, right? So sine function starts out as 0. It first goes up to 1, right? And then it goes down to 0 again. Then it goes down to -1, and it keeps going in both directions, something like that, right? This is a sine function, right? Y equals sine of x, right? Okay, so, and of course it attains this 1 at pi by 2. Yeah, pi by 2, right? Pi by 2, right? Y equals, no, x equals pi by 2. X equals pi by 2 and y equals 1. Yeah, so that's the maximum of the sine function. But okay, so anyways, we don't care about the maxima and minima right now. All we care about is this is an odd function, right? And we can say that it's odd because we can rotate it about the origin such that it returns to its original place after rotation of 180 degrees, something like that, right? So therefore, for okay, let me see, write this. F odd, we have that f of x minus f of x equal to f of minus x, right? So that is a property of odd functions, right? Okay, so that's what we've used here. Now again, so I'm just gonna draw the cosine function too, right? Because we're gonna be using that again. So the cosine function, it's kind of like the sine function, but it starts at 1 and goes down to 0 at pi by 2, goes down to -1 at say 3 pi by 4, yeah, and goes back to 0 at 2 pi. No, wait, uh 0 pi by 2, 3 pi by 4, 2 pi, yeah, pi, sorry, not 2 pi. And yeah, from here to in the negative side, similar stuff, right? So that's that. So yeah, that's pretty clear. This is y equals cosine of x. I should write this properly, right? Sine of x, okay? Cosine of x, sine of x, right? This is at 1, this is at pi by, this is it at pi by 2. So, well, you can see that the sine function is just pi by 2 ahead of the cosine function. It's visible. I mean, okay, not really because it's a bad drawing, but well, you can tell, right? Because pi by 2, 1, then pi by 2, 0, but it's supposed to be here. So if you move the sine function towards the left by pi by 2, or you move the cosine function towards the right pi by 2 by pi by 2, then you get the sine function. So they're related in that sense. They just shifted functions of each other. So we have cosine of 3x, and we're going to use that property exactly as cosine. So now we convert this sine to a cosine. Now, well, so since this is pi by 2 shifted, then sine of minus 3x is cosine of pi by 2 plus 3x. So it's really pi by 2 minus 3x, but that becomes plus 3x, right? Yeah, Apologies, that was out of the frame. Didn't realize. Anyway, so now, well, we have the following equation, right? Cosine of something is equal to cosine of another thing. Well, now, okay, so if you think about this, right? If you just go blatantly and say, well, that must mean that 3x is equal to pi by 2 plus 3x, then I think you should, like, you get 3x and 3x cancel out, and 0 is equal to pi by 2, which is like very wrong in the first place. But then again, you're really removing x from the equation. Even if you like add some period of 2 pi or something on one side, you're removing 3x. So we have to think creatively here, right? So what's a property of the cosine function, right? The cosine function, well, it's an even function, and an even function, so let me write for g odd. We have,
God, please, no! 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 No!
have the g of minus x is equal to g of x, and vice versa. This goes both ways. Of course, that's inequality. So g of minus x is equal to g of x. Well, then let's call x pi by 2 plus 3x. Oh, I just realized I've used x everywhere. I should use like some z maybe. Not complex, but just deal with it. Just a variable. Okay, don't overthink. So, let's consider z to be pi by 2 plus 3x, right? So in this scenario, that should mean that this is equal to cos of minus pi by 2 minus 3x cos of 3x. Well, this is pretty cool. And from now, so now, I mean, okay, we're not going to blatantly just put it in there, because the cosine function and the sine function, both of them are periodic functions, right? So that means that if something is true for x, then it's also true for x plus 2 pi, right? There were a period of 2 pi, right? 2 pi. I'm not dumb. Okay, so wait, no, this is pi, this is okay. I'm actually kind of confused, but okay, whatever, it doesn't matter. This is pi by 2 and the other things don't matter, right? So anyways, 3x is equal to minus pi by 2 minus 3x, but we have to consider the fact that after every 2 pi it can be the same. So just add 2k pi, where k is an integer. It can be any integer, it can even be before it, right? Because it repeats on both sides. So from here on, I think it's fairly basic to solve it. So we move the 3x here, we get a 6x is equal to minus pi by 2 plus 2k pi. Then we divide by 6 on both sides to get x is equal to minus pi by 12 plus k pi by 3, right? Well, this is actually very cool, right? So of course we want them from 0 to 2 pi. Yeah, so as I was saying before I got interrupted, we want the answer to be from 0 to 2 pi, because this is clearly outside the domain. If you ignore this part, I mean, you should ignore this part, right? Because we should only get one solution, realistically speaking. So what we want is a solution inside this domain 0 to 2 pi, but this is clearly less than 0. So if we're gonna create another variable, but it's not really a variable because it doesn't matter, it's more like a constant. So m we're gonna create an m such that, okay, so m should be k minus 1, right? Yeah, okay, so k is m plus 1, right? It should be pretty clear, and in about a second you'll know why I'm doing this, right? So so k is m plus 1, right? So plus m pi upon 3 plus pi upon 3, right? What I've done is I've just, okay, so we had, okay, you know what, let's just do this from like, really, let's just build this from the bottom up. So m plus 1 times pi upon 3, right? This is what we had. And so now we expand this m plus 1. So you open this bracket, right? So minus pi by 12 plus pi by 3 plus m pi by 3. Now just notice that this is still like for all integers m, but now it's more like it doesn't matter because it still holds for all integers, and integers, like, shifting them doesn't change what they are. So anyways, so we have that. Now we have these two, and of course this is clearly greater than this, which is why I did what I did do. So now let's get a common denominator. So note that this is 12, this is 3, right? So the LCM is 12. So we need to multiply this by 1, but that doesn't matter. We need to multiply this by numerator and the denominator by 4. So we get minus pi by 12 plus, well, if my marker would work, plus 4 pi by 12, right, plus m pi by 3. Now these are all values for our x, right? Right now we're just solving for x to get it inside our domain, range, I mean. Well, yeah, range or domain, I don't know, one of the two. Anyways, so yeah, we have that. So now we can simply combine these. So we get x is equal to, well, 3 pi by 12, that's, you cancel out the 3's, and we get pi by 4. Yeah, pi by 4 plus m pi by 3, right? Where m is just an integer, because yeah, m is just an integer. So we can say that m is just an integer because of the, let's see, because the integers are closed under subtraction. Let's use like absolute math language. The integers are closed under subtraction. So so if k is an integer, then k minus 1 is always an integer. Yeah, absolutely official math language. So what we've got is k equals pi by 4, and if you're not used to radians, then, well, I mean, I guess you should get good at life, but yeah, the jokes aside, if you're not used to radians, then this is, well, equal to pi by 4. Now we can ignore this part, right? Because if we add another, well, let's see how many more can we get. Let's if we add another pi by 3 to this, right? Pi by 4 plus pi by 3, that's gonna be 3 pi by 12 plus 4 pi by 12 plus 7 pi by 12, which is still in our domain, but this is one of the answers. Yeah, I guess there's many more answers, but this is still in our domain, so yeah, whatever. Yeah, so if you're not used to radians, right, pi by 4, then I'm gonna write this in degrees. So 180 by 4 can be 45, if I'm not wrong, and 180 by 3 is 60. So yeah, 45 equal to 45 degree plus 60 times m. Yeah. See, that's why, like, I'm not that much of a fan of degrees. This part looks really weird. This part is fine. This part is really weird. Anyways, so yeah, we have this, right? So let's check our answers. So cosine of, well, what is that? 45 times 3 is 135. Well, cosine of 135 is, so 135 is 45 more than 90. So yeah. So what we're claiming is cosine of 135 degrees is equal to minus the sine of 135 degrees, right? Yes. So, well, this is 90 plus something, and that's just going to be sine of something. Okay, so that's going to be sine of 45 degrees is equal to, and this is 90 plus something, it's going to be cosine of something. Wait, Oh no, that's bad. Well, anyways, yeah, cosine of 135. Let's think of this in terms of like the what is it called? Unit circle, right? If my marker would work, right? Okay, so cosine 135 degrees. What we want is 135 degrees. So this is 90, and so this would be around 60. This should be around 120. So about there, 135 degrees, right? We know that, okay, no, 135 degrees is not the coordinate. It's this measure, 135 degrees, right? So we know that the coordinates are, okay, so cosine of this angle is what was that? It's like x. Yeah, the x coordinate is cosine of 135, and the y coordinate, well, 135, right? So yeah, this would be 45. Yeah, okay, so it's pretty easy to see. If this is 45, right, then and this would be 90 degrees because I've just dropped that altitude there. So 90, so yeah, so sine of 45 would be, well, opposite over hypotenuse. So, and the hypotenuse is 1, so that would be just the y coordinate, sine of 45, right? Then the cosine of 45 would again be the same. Yeah, so basically we've just, yeah, so it's like, okay, so 180 minus 45, right? So yeah, so sine of 45 is this y coordinate, but in terms of this, yeah, well, I can't do trigonometry, that's fine. Okay, so 45, and then this is sine of, yeah, basically you can see that they're equal, right? Because this angle is 45. So for the cosine, we'll just have the x coordinate, which is here, right? And for the sine, we'll have the y coordinate. And one of them has to be negative, and they're equal because 45 and 45. So yeah, I think it's visible. Why so bad at this? Because it's in like the second quadrant and blah blah blah. I don't remember stuff. But anyways, this is like hence verified kind of. But okay, so let's just find all the solutions, right, within our domain. And I'm gonna rearrange this degrees part because it's annoying. No one likes it. Anyways, yeah. So bye bye. Okay, so we're gonna find all the solutions. So, well, I'm just gonna do this in my head because at this point, yeah, this video is just gonna be too long if I don't. Okay, so we have pi by 4 at first, and then we have 7 pi by 12, I think. So this was 3 pi by 12. Then we'll get 7 pi by 12. If my marker would work, we would. 7 pi by 12. Then we'll have 11 pi by 12, if I'm not wrong. Then okay, so I think we're supposed to go until like 24. So like every 4, I think. Yeah, so then 15, right? Yep. So then just 15. If my marker would work again. 15 pi by 12. 19 pi by 12. 23 pi by 12. So these are all the solutions. We have 1, 2, 3, 4, 5, 6. 6 total solutions, right? Yep. So this question was overall pretty nice until I started doing that checking part. Yeah, that was simply dumb. But okay, so this part was like very nice. Question was like very nice. And you know, there were other approaches. They used identities. I mean, the identities were pretty simple to derive, but you know, it would have been annoying. I don't like identities, right? This is more of a logical answer, and It was a creative approach. So yeah, just wanted to share this one with you guys. Anyways, subscribe.